let us see how to integrate 1 upon 1 plus x cube. Okay, we know that integration, this is not a direct integration. There is no direct formula available. We have direct formula for 1 upon 1 plus x integration. We know this is log x, log mod 1 plus x, right? We know integration of 1 upon 1 plus x square. So if it is power 2 and there is plus in between, we know this is tan inverse of x. We know these are standard formulas. These are direct available formulas to us. But since it is power 3, there is no direct formula available. Okay, so we have to use a little trick here. Okay, we have to use a little trick. This is just like polynomial over polynomial. Power of the denominator is 3. Let's see if we can use partial fractions. Partial fractions can only be used if you can factorize the denominator. Okay, let's see if we can factorize the denominator. We know that 1 plus x cube, 1 plus x cube can be written as 1 cube plus x cube. 1 cube plus x cube. We know from algebra the formula for a cube plus b cube. We know the formula for a cube plus b cube is a plus b into a square minus ab plus b square. We know this formula. We can use that formula here. This is just like a cube plus b cube. So 1 plus x, a square, 1 square is 1, minus ab, so 1 into x is x, plus b square, which is x square. Okay, so we can simplify that 1 plus x cube like this. So now our integration I will become integration of 1 upon 1 plus x into 1 minus x plus x square into dx. Okay, we can simplify this like this. Now we can apply partial fractions here. We can say that since it is product of two numbers, or we have factorized the denominator, we can say that let 1 upon 1 plus x into 1 minus x plus x square be equal to a upon 1 plus x plus. Okay, remember that this is quadratic. If it is quadratic, we have to write in the numerator linear term bx plus c upon 1 minus x plus x square. Remember that if it is power 1, numerator is power 0. Here it is power 2. So the numerator has to be power 1. Okay. So this is, you can simplify it like this using partial fractions. You can say that let this fraction be is equal to a divided by the first term and bx plus c divided by the second term. Because it is quadratic, so you have to specify the linear term in the numerator. Okay. It's a very interesting question. Okay. Now, in order to simplify this, what you can say, therefore, just do cross multiplication here. So you get 1 upon 1 plus x into 1 minus x plus x square is equal to a into, just multiply this over here, 1 minus x plus x square plus 1 plus x into bx plus c, 1 plus x into bx plus c divide by product of these two, 1 plus x into 1 minus x plus x square. This and this will get cancelled here. So therefore, we will be left with 1 is equal to a into 1 minus x plus x square plus 1 plus x into bx plus c. Now essentially we have to find the values of a, b and c. We have to find the values of a, b and c, and then we can substitute it back over here. All right. In order to find the values of a, b and c, you can just assume random values of x. To start with, let's make three columns here. Let's make three columns. To start with, let's say x is equal to 0. You can assume any random values, you will get the right result always. Just assume 0. So this two terms will become 0. On the left hand side, we have 1 is equal to, here you will get a, this 2 will become 0. So this you will get 1, 1 times a is a, plus here you will get 1, and then here you will get c. So we know that a plus c is 1. This is equation number 1. Let's assume another value. Let's say 1. Just take small values so that it's easy for you to calculate always. Then you get 1 is equal to a into, now 1 square is 1. 1 minus 1 is 0. This will again become 1. 1 plus 1, this will become 2. And b plus c. B plus c. All right. So therefore you get 1 is equal to a plus 2b plus 2c. Okay. Let's put x is equal to minus 1 and we get 1 is equal to, if you put minus 1 over here, this will become plus 1, right? Because it's already minus. So 1 plus 1, 2, and this will become plus 1 because minus 1 square is 1. So 2 plus 1, this will become 3a plus, and this, if you put minus 1, this will become 0. Okay, this will become 0. So from here straight away, you have a is equal to 1 by 3. A is equal to 1 by 3. You can substitute that a over here and then you get, therefore c is equal to, if you put 1 by 3, so you get c is 1 minus a, therefore c is equal to 1 minus 1 by 3, c is 2 by 3. You get value of c as 2 by 3. All right, and here you can put a and c over here and then you get 1 is equal to, just put a is 1 by 3 plus 2 into, we need to find b, plus 2 into c is 2 by 3. Right? I hope that makes sense. Then therefore you get 1 is equal to 1 by 3 plus 2b plus 4 by 3. All right. I hope that makes sense so far. It's very easy. Okay, not too difficult at all. Therefore, 1 is equal to, so this 4 plus 1, 5 by 3. So you get 1 minus 5 by 3 is equal to 2b. Therefore, you get minus 2 by 3 is equal to 2b. And this 2 and 2 will get cancelled. Therefore, you get b is equal to minus 1 by 3. Very easy. You just have to assume some random values of x and you will always start with 0. Take small values like 1, minus 1, and you will easily find the values of a, b, and c. This is a very interesting problem. It will cover so many. It will cover partial fractions. It will cover completing square. It will cover a lot of important concepts for you. Okay. Now we can substitute the values of a, b, and c over there, and therefore we can get integral I is equal to integration of, if we put a upon 1 plus x. So a is 1 by 3, so we get 1 by 3 upon 1 plus x. Okay, and then we have plus bx plus c, b is minus 1 by 3, so we get plus minus 1 by 3x plus c is 2 by 3, divide by denominator is 1 minus x plus x square, 1 minus x plus x square into dx. That's our integral. Okay, very easy so far. We use partial fractions to find the values of a, b, and c. Therefore we can say I is integration of, we can split the integration in different parts. We can give integration to both of those. We can say 1 by 3 upon 1 plus x plus, or we can write dx here, plus integration of minus 1 by 3x plus 2 by 3 upon 1 minus x plus x square dx. Okay. All right. Now, if you observe very carefully, derivative of this denominator, if you look at the denominator, derivative of this denominator is 2x minus 1. Okay, derivative of this is 2x minus 1. Can we adjust that 2x minus 1 in the numerator? Let's try to bring that term in the numerator so that we can easily do method of substitution at this point. Okay, so in order to do that, what you do is, therefore say I is equal to, this integral we can evaluate directly. 1 by 3 is constant, can be taken out of integral, and we get log mod 1 plus x, okay. And in order to do this, what you do is take 3 common first, 3 common. So we get 1 by 3 out of integration. That 1 by 3 can be taken out. And we have integration of minus x plus 2 divide by 1 minus x plus x square dx. Remember, we have to adjust that 2x minus 1 here. Okay. So therefore, we have I is equal to 1 by 3 log mod 1 plus x plus 1 by 3 plus 1 by 3, And so we need to adjust 2x minus 1. So what you do is first you multiply and divide by 2. Okay. Also, since we need plus 2x, this minus also take it out. So just take minus out of the numerator. So that will first become, instead of minus x plus 2, it will become x minus 2 now because we are writing the minus sign here. And you get 1 minus x plus x square. So we are trying to adjust that derivative 2x minus 1. So therefore, our I will become 1 by 3 log mod 1 plus x minus 1 by 3 integration of. Now, since we need 2x, multiply and divide by 2. So multiply by 2. So you get 2x minus 4. And then you divide by 2. Then you divide by 2 on 1 minus x plus x square dx. Okay. So now this will become minus 1 by 6 integration of. Remember that we need 2x minus 1. We already have 2x. We need minus 1. So we'll write that minus 4 as minus 1 minus 3 over 1 minus x plus x square dx. So we were able to adjust 2x minus 1 in the numerator. Okay, 2x minus 1 in the numerator. So therefore our I will become 1 by 3 log mod 1 plus x minus 1 by 6. Let's put a bracket. And let's now split this term in both of those. Let's now split that term. So we get 2x minus 1 upon 1 minus x plus x square. Okay. Remember that there is an integration here. Okay. There is an integration. Minus 3 upon 1 minus x plus x square dx. Okay. It's such a beautiful question. It will check all your integration knowledge. 1 upon 3 log mod 1 plus x minus 1 by 6. Let's put a bracket and let's give away this integration to both of those terms. So we have integration of 2x minus 1 upon 1 minus x plus x square dx minus integration of 3 upon 1 minus x plus x square dx. Okay. Now we have two integrations to evaluate. We have two integration. We have this is first integration, which is I1, and then we have this second integration I2. We have these two integrations to evaluate now. Now, in order to evaluate I1, it's very easy because integration, we have derivative in the numerator. So we have 2x minus 1 upon 1 minus x plus x square dx. Since this is direct derivative, we can say let 1 minus x plus x square b is equal to t. Okay, so just differentiate this. So we have minus 1 plus 2x is equal to dt by dx. Differentiate that with respect to x. So therefore 2x minus 1 dx, 2x minus 1 dx is equal to dt. Okay, 2x minus 1 dx is equal to dt. So this 2x minus 1 times dx becomes dt. So therefore your I1 will become, integration of, so this will become dt, the numerator will become dt upon t. Okay, and this will just become log mod t. This will just become log mod t, which is log of 1 minus x plus x square. So we evaluated this integral I1, which is log mod 1 minus x plus x square. Now we need to evaluate second integral, which is I2. We need to evaluate the second integral, which is 3 upon, which is I2 is integration of 3 upon 1 minus x plus x square dx. Now, since it is 1 upon quadratic, we have to do completing square method. So in order to do completing square method, what you do, first take 3 out of integration. We have 1 upon 1 minus x plus x square dx, 3 integration of. Now, in order to completing square method, check the coefficient of x square. It should always be 1. That's the first thing you always check. Okay. Whatever the coefficient of x is, you divide that by 2 and square it. Okay. So minus 1 is the coefficient of x. You divide by 2 and square it. So you get 1 by 4. So what you do is 1 upon, you add 1 by 4 and subtract 1 by 4 now. So you get x square. So start with the higher term and then go in the descending order. Okay. X square minus 1x, and then you add 1 by 4, then write this plus 1, then you subtract minus 1 by 4. Basically, what you're doing is you're just adding this term and subtracting the same term to nullify it. And how do you find the term? You divide by 2 the coefficient of x and square it. What this is going to do is this will become a square minus 2ab plus b square. So if you notice this term, this is always going to be x minus 1 by 2 the whole square. You just do x and then a square root of this, the whole square. If you expand this bracket, you will notice you will get the exact same term. This will always happen because we are applying this technique. This is always going to happen. Okay. And plus 1 minus 1 by 4 is nothing but 3 by 4. Okay. Okay. Now, in order to integrate this, let's first write with respect to x here. Let's not forget dx. In order to integrate this, remember this 3 by 4 is nothing but root 3 by 2 the whole square. It's root 3 by 2 the whole square. Now we know the formula of 1 upon 1 plus x square dx, or we should say 1 upon a square plus x square. We should say integration, we know 1 upon x square plus a square. This is nothing but 1 upon a tan inverse x upon a. That's the formula that we are going to use for integration. So that is going to give you 3. We just use that formula. Remember, a is root 3 by 2. A is root 3 by 2. So we get root 3 by 2 tan inverse x minus 1 by 2 divide by root 3 by 2. That's the integration that we get, okay, for that term. Uh, yeah, so basically now we can substitute that integration. We can substitute that integration in our final result. So we can just copy this entire integral over here. Let me copy that. Let me copy that integral. Let's copy that integral and I'll just paste it here. We already have the result now, okay? We already have the result. This is dx. We found I1 and this I2 also we found. I2 is 3 root 3 by 2 tan inverse x minus 1 by 2 upon root 3 by 2. And that's your final result. That's this whole entire thing is your final. So if I want to write the final result, it is 1 by 3 log mod 1 plus x minus 1 by 6 log mod 1 minus x plus x square minus 3 root 3 by 2 tan inverse. This 2 can go in the numerator because it's in the denominator's denominator. 2x minus 1 upon root 3. Because this 2 will just multiply here. 2x minus 1 divided by root 3. Plus let's add the constant of integration c. And that's your final result. Such a beautiful question it is. Okay. Thank you.